In this lesson, you're going to learn all about slope. Slope is just the steepness of a line. Slope is referred to as several things. It's referred to the rise over the run of a line. I also say that this is the change in y, which is written with this triangle, divided by the change in x. Typically, we use the letter m to represent slope. If you're given two ordered pairs, you're going to use this formula here to calculate slope. So the slope of a line fits one of four cases, okay? You read graphs from left to right. So for this one, because it's uphill, it's going to have a positive slope. Downhill is negative. Completely horizontal has a slope of 0, and a completely vertical line has an undefined slope. Now, if the slope is positive, you need to give it a number associated with it that actually measures the steepness, like positive 1/2, or in this case, maybe it's negative 2, okay? We will actually look at how to get that value next. So for each of these graphs, we're just going to count the slope of the line, so I'm going to zoom in here. What I typically do is I find where the graph hits in the corner of a grid. So I see making some big old points here. You can count the slope between any 2 points on that line. And again, slope is your change in your y over your change in your x, and I use the letter m for it. Because this is uphill, I know my number should be positive, so I count. I'm going to count up 1, 2, 3 units. So my top number is 3. And write 1, 2 units. So 3 over 2, and I check to see if that reduces. It doesn't, so my slope is 3/2. Now, I just want to point out, you could count up 1, 2, 3, 4, 5, 6, and then write 1, 2, 3, 4. So if you did that, it would be 6 over 4, but notice that it reduces to 3 over 2. The slope of a line is constant, meaning whatever 2 points I count the slope in between, it will be that for all points on that line. All right, let's look at one more here. Because this one is downhill, this slope will be negative. Find any 2 points on the line, so I make them kind of exaggerated. I'm going to do between these two. And I start at the leftmost point and I count my rise, or my change in my y first. So it's down 1, 2. Because it's going down, that's a negative direction on y. To the right, then 1, 2 is a positive direction. So it's negative 2 over 2, which reduces to negative 1. So my slope, represented by m, is negative 1. Sometimes you're given ordered pairs. So one thing that you can do is just graph the ordered pairs, which I'm going to do here. Negative 2, 2, and then 2, 5. I'd connect it with a straight line, and now I'm going to count that slope. So my rise over my run. So I'm going to count up 1, 2, 3. And my run, 1, 2, 3, 4 to the right, does not reduce, so it's 3/4. Next would be negative 2, negative 5, negative 2, 2. Draw my line. This is one of our special cases. Do you know the slope? Hopefully you said undefined. This has, if you would actually count the rise, you could count up 1, 2, 3, 4, 5, 6, 7 points. But it doesn't change at all, and if you would ever try this on your calculator, you get an error because you cannot divide by 0. So this is one where we actually write a word, undefined, for our slope. And number 5 here, plot your points, 1, 2, and 5, negative 2. All right, I would like you to count the slope of this line. So my rise is down 1, 2, 3, 4 units. So my top number is negative 4, and then I go right 1, 2, 3, 4. And this reduces to negative 1. Now, always graphing 2 points, plotting them, and then counting the slope can be cumbersome, especially if your points are far away. So the other strategy would be to use your formula, which is given here on the screen. Y2 minus y1. So this is finding the change in the y's divided by the change in the x's. So strategy that's always good to do is to label your points, x1, y1, and then x2, y2, And let's do our formula. So we are going to subtract y2, which is 4, minus y1, which is 2. And then on the bottom, x2 is negative 3, minus x1 is 1. All right, so let's do the math. 4 minus 2 is 2. Negative 3 minus 1 is negative 4. This fraction reduces to negative 1/2. So this would be a downhill line. Number 7, let's do our slope. Again, I label my points x1, y1, x2, y2. I'm going to subtract my y's, so this would be 2 minus negative 6. Common mistake there is that kids put 2 minus 6, 2 minus negative 6, over negative 5 minus 7. All right, so what's this become? 2 minus negative 6 would be positive 8. And negative 5 minus 7 would be negative 12. So this reduces to negative 1, make that negative 2/3 rather. So would this line be uphill or downhill? It would be downhill. All right, I would like you to try 8 now on your own. Press play when you're ready to check your answer. So when I do this, I get 8 over 0, which is undefined because I can't divide by 0. So what type of line would this be? It would be a vertical line. All right, number 9, quickly, let's do our formula. On the top, we have 1 minus 1. On the bottom, 1 minus negative 9. So this would be 0 over 10. Well, 0 in the numerator is 0. So what would this line look like? It would be completely horizontal. All right, we've got a great question now. It says, graph a line that has a slope of negative 2 and passes through negative 3, 5. All right, so I know the steepness, and I also know a point that anchors it. I'm going to start by the point that anchors the line and negative 3, 5. So go left 3, up 1, 2, 3, 4, 5. Right here. And now I count a slope of 2. Or a negative 2. But what I always do is I change my slope to a fraction, okay? So I may get negative 2 over 1, and then I think, okay, so rise. Well, since it's negative, I'm going to drop. Since the bottom's positive, I'm moving to the right. So I go down 2, right 1. Do it again. Down 2, right 1. Again. And again. And again. And good practice is you go until you reach the end of the coordinate plane. Now I could flip everything and go up to left 1 to continue that line. Connect it. And make your beautiful straight line, and that line has a steepness of negative 2.